Hello, 8th grade Grizzlies. This is Miss Brown, and this is going to be a review for your Cosmos test. So throughout the video, it's going to pause and give you an opportunity to answer the questions. I would strongly encourage you to answer each question because some of them you will probably see on your test. Hint, hint. All right, so let's go ahead and begin. So we started this unit, Cosmos, talking about components of the universe. All right, so we started off talking about a solar system, which is the group of 8 planets, including the comets, asteroid belt, meteors that orbit the sun. Okay. You will need to know the size comparisons, which I will get to in a moment. All right, a galaxy, a giant structure that contains dust, gas, and billions of stars. Okay. The next thing we talked about is galaxies. This one over here. So, we talked about the 3 shapes of galaxies. All right. So we have the spiral, which looks like a pinwheel. So this is a spiral. All right, and that one looks like a pinwheel. We have the elliptical, and that one is football shaped. And then we also had the irregular. Okay, and this one really has no shape. Okay, the main thing you need to know about the galaxies is that we live in a spiral galaxy. And of course, our galaxy's name is the Milky Way. And our solar system is located on an outer arm. Okay? You will be asked this on your test. Where is our solar system located? We are on the edge of an arm. We are not in the center, we are on an arm. Okay? So make sure that you know that because you will be tested on that. Okay. Going back to the graphic organizer, here we talked about the universe is space and everything in it. And make sure you understand that most of the universe is empty space. Okay, so the universe does have planets and stars and galaxies and everything, but most of the universe is empty space. Make sure you know that. Okay, next we talked about gravity. That's the force that governs the universe, and it also keeps galaxies from breaking apart. Okay, so the gravity is what holds galaxies together. Okay, nebula is a cloud of gas and dust where stars form. I'll talk about that when I go over the life cycle of a star. And we also talked about nuclear fusion in relation to what a star is, and I will go over that more in depth. And also our sun being a medium-sized star, I will go over that in depth in a moment as well. Okay? Okay, so I am going to move on, and we are going to talk about the life cycle of a star. Okay, so remember, mass Mass determines the life cycle of a star. Okay? So remember that. You will be tested on that. Mass determines the life cycle of a star. Okay, so here we go. So I'm going to go ahead and draw out the life cycle of a star. So all stars begin as a nebula. A nebula is a cloud of gas and dust. Okay? This is also called a star nursery, because this is where stars are born. Okay, so gravity pulls all that gas and dust together, and you have a protostar. Okay, the protostar is where nuclear fusion begins. Okay. And nuclear fusion is when hydrogen fuses together, or it melds or fuses to make helium. All right, so this is where you have two hydrogen atoms. They fuse together and make helium. I'm sorry, I'm trying to adjust the focus there. All right. So nuclear fusion occurs in the core, and this is what causes this star to shine. All right, after a protostar, all stars go into the main sequence. All right. Now, this is where the mass will determine the life cycle of the star. Okay. So we're going to look at what a low mass star does and what a high mass star does. So over here we have low to medium mass. Okay. So this is what our sun is, a low mass or average mass star. So this is the path that our sun is going to take. Okay? So after it is a main sequence for billions of years, it will become a red giant. After the red giant, it will become a planetary nebula. After the planetary nebula, it will be a white dwarf. And this is where it's running out of fuel. And then our sun will eventually die as a black dwarf, which is a dead star that does not shine. Okay? So please remember, this is important. Right now, at this very moment, our sun is in the main sequence. It is an average mass yellow star in the main sequence. And this is the path that it's going to take, because it is a low or medium mass star. Okay, now your more massive stars, your high mass stars, will take this path. So we're going to label this high mass stars. Now remember also, high mass stars do not live as long as low mass stars, because they are so massive they burn through their fuel much more quickly than a low mass star. Okay, so remember, high mass stars will don't live as long as a low mass star. Okay, so a high mass path, when it starts to die, it will become a red supergiant. After the red supergiant stage, it will explode in a supernova. Now, a high-mass star can die two different ways. It can die as a black hole, and I want you to put a star here. This is what most high-mass stars do. Most high-mass stars die as a black hole, or they end their life as a black hole, or it can be a neutron star. All right. You have this chart very similar in your notes. I'm just writing it out in the video just to give you a visual, but you do have these in your journal. All right. I talked about fusion a little bit. I just want to draw out another diagram, something that you might see on your test. Okay, so we talk about nuclear fusion. Okay, remember we said it occurs in the core. And that's where you have hydrogen. Okay, so hydrogen atoms, and then they're going to fuse, and you will get helium energy. Okay, so you might on your test see something like this. Okay, and these fuse together and you get helium and energy. Okay, so make sure you know hydrogen fuses to make helium and energy, and that's what causes the star to shine. All right, so moving on, we are going to move on and talk about HR diagrams. Okay, so HR diagrams, HR diagrams, your y-axis tells you the luminosity, brightness, or magnitude. Luminosity, brightness, and magnitude, they all mean the same thing. So if it asks about how luminous a star is, what its magnitude is, or what its brightness is, that all is referring to brightness. Okay? So as you go up the HR diagram, okay, on your y-axis, this is your y-axis, your bright stars are at the top, and your dim stars are at the bottom. Okay? You also want to remember that your x-axis is temperature. Now remember, your temperature increases as you go from left to right. So your temperature increases as you go, from right, oops, I said that wrong, disregard, increases as you go from right to left, So as you go from right to left, your temperature increases. So you're going to have your cool stars here, and that might be 2,000 degrees. And your hot stars are over here, and that could be 50,000 degrees. So from going from right to left, your temperature increases. Okay? All right. So you do need to know the general locations of stars on HR diagrams. But I want to show you a little trick that you can use when you get your test. If you see an HR diagram, divide it up, okay? So, left side, the stars are going to be hot, okay? Hot stars are on the left. Cool stars are on the right. Now, in terms of brightness, your bright stars are at the top. So on the left, upper left, you have hot and bright. On the right at the top, you have cool and bright. And your dim stars are at the bottom. So the bottom is hot, but they're dim. And then the bottom right, they're cool and they're dim. So if you get an HR or you see an HR diagram on your test, you can divide it up into these four corners like that, and it will help you answer questions. Okay, so the next thing you will need to know is that most of the stars are right here in your main sequence. Okay, the sun is about right here. Sun is a main sequence star. It's about 5,500 degrees Kelvin, and it is yellow. All right. Over here, you're going to have your giants. And here at the top, you're going to have your supergiants. And then over here, you're going to have your white dwarfs. Okay. So you will need to know in general where these are located on an HR diagram. Okay, and do know this information about the sun. All right, another thing you will need to be aware of for your test is that the HR diagram compares temperature and brightness. So when you look at this HR diagram, it'll tell you the luminosity, brightness, or magnitude. Remember, those all mean brightness. It will tell you the temperature of the star. Okay. It will also tell you what category, whether it's a supergiant, giant, main sequence, or a white dwarf. One thing the HR diagram does not tell you is where a star is located in the universe. That information is not on an HR diagram. Okay, so just be aware of that. You also want to be aware that some HR diagrams will have the colors at the top. So it would be blue, white, or white. Yellow, orange, or sometimes you might see red, orange, and red. Okay. So the HR diagram can also tell you the color of the star. Okay. Remember that blue stars are hot, red stars are cool. All right, and the last thing that I'm going to go over that you'll need to know for your test is apparent and absolute magnitude, which is the last topic that we discussed and did practice on last week. All righty, so let's start with apparent magnitude. So apparent magnitude is the brightness of a star as seen from Earth. So this is how we see it. Okay? So that's apparent magnitude. Absolute magnitude is the actual the actual brightness of a star's true brightness. So for example, the sun's apparent magnitude, it appears to be the brightest star because it is the closest to us. But if we were to be able to line all the stars up in a row with the same distance as the sun is from us, we would see that the sun is not the brightest star. It is just an average star. Okay? So absolute magnitude is the actual brightness, and apparent magnitude is the brightness as we see it from Earth. Okay? So a couple of things I'm going to write down here at the bottom just to remind you. So the more negative the number, that means that that star is brighter. Okay? If it is a positive number, it is dim. Okay? And we did this on the worksheet practice that you did in class. So if I have a star whose apparent magnitude is negative 4.5, and I have another star's magnitude that is negative 2.5, this star is going to be brighter because it is the more negative number. Okay? If a star's magnitude, if it's a positive number, it's going to be dim. So if I had a star's apparent magnitude, let's say, was 2, and another one that was 7, the one that's 7 is more dim than the one that's 2. Okay, so that's basically the worksheets that we, the star magnitude worksheets that we did in class, where you looked at the apparent and the absolute magnitude. Remember, when you're looking at apparent magnitude, it's how it appears. So apparent is how it appears from Earth. Absolute is the actual. Okay? All right, 8th grade Grizzlies. I think that just about wraps up everything that you will need to know for your test. I would encourage you to make sure that you have answered all of the questions in this video. If you have any questions incorrect, you can go back and re-listen to the video and redo the questions just to make sure that you understand everything. And go make sure you look through your notes and ask us any questions. And if you understand everything and have been able to correctly answer most of the questions in this video, you should do very well on your first test of the school year. All right, Grizzlies, study hard and good luck.